Hey guys, here we are again with another video lesson notes. This is on section 7.3, which is the Pythagorean theorem. So the Pythagorean theorem is brought to us by this guy, Pythagoras. He was alive around 500 BCE, and he did a whole lot of work with mathematics and geometry in particular. His greatest accomplishment, he's most well known for, is the Pythagorean theorem. So before we get into the actual theorem itself, let's talk about the sides of the triangle. So whenever we look at a right triangle has three sides. It has the two legs, and it has a hypotenuse. So the hypotenuse, it's easy to find. It's always the longest side, and it's also opposite of the 90-degree angle. So when you look at a right triangle, whatever side is the longest, that's going to be the hypotenuse, totally. Well, if that's the hypotenuse, that means the other two legs, their two sides, must be the legs. When we do this whole Pythagorean theorem thing, it doesn't really matter which leg is which. I call this bottom one leg A and the right one leg B. It could be either one. Just note the hypotenuse is always the longest side, and the other two are the legs. All right, now let's actually do the Pythagorean theorem, and let's actually apply it. So we saw in class, we did an experiment. We found that anytime we have these right triangles, if we take the side length of A and square it, we add that to the square root of side B, and it ends up equaling whatever the hypotenuse is squared. So if I'm trying to find the hypotenuse in a triangle, what I can do is, well, I can just plug in whatever the leg lengths are, and I can solve for the hypotenuse. So let's see how that works. Let's say I have a triangle, and it's like this, right triangle here. I know it's a right triangle, and its two side lengths that are given to me are 3 and 4. And now I don't know the hypotenuse yet, but we're going to use the Pythagorean theorem to find out how long that unknown side is. So the first step we're going to do is just, well, write down the Pythagorean theorem. A squared plus b squared equals c squared. Once we have the formula written down, all we're going to have to do next is just plug in the known values. So again, it doesn't really matter which side is A or B. I'm going to use this 3 here for my A, and I'm going to use this 4 here for my B. So those are my two legs, A and B. I'm going to plug those into my equation, and I'm going to use them to solve for that unknown hypotenuse. So here we go. I'm going to plug in the 3 and the 4. So I have 3 squared plus 4 squared equals c squared now. Again, all I've done is add in the A and the B. And now I'm going to go ahead and just kind of solve this out. I'll start off by evaluating my 3 squared and 4 squared. I know 3 squared is 9, and 4 squared is 16. So I'm going to write 9 plus 16 equals c squared. Now I'm going to combine my like terms, 9 plus 16, which gives me 25. And I get 25 equals c squared. Now that is not the length of my hypotenuse though, right? So don't get tricked by that. That's c squared. That's that hypotenuse squared. So if I need to find just c, well, I'm going to take the square root, right? Anything I do to one side, I've got to do to the other. So I take the square root of both sides, and well, the square root of c squared, well, the square root and square will just cancel off, leaving me with a c, and the square root of 25 is 5. And there we have it. Our unknown side of that triangle is 5. Totes. Now, it does get slightly more difficult. It could be a case like this where we don't know one of the legs, but we have the hypotenuse. And remember, the hypotenuse is always that long side. To find the leg, it's the same procedure. We're just going to start off by writing the equation. A squared plus b squared equals c squared. Next, I'm going to plug in all my known values, which is just the a squared and my c squared, right? Does everybody see where I've gotten these from? And again, my hypotenuse is c. That's this guy here, because it's the longest side, and it is opposite of the 90-degree angle. Totally. So now I'm going to go ahead and evaluate this 2.1 squared and 2.9 squared. Oh, golly. 2.1 squared. Here, let me do that real quick. 1 squared would be 2.1 times 2.1. So that would be 1 times 1 is 1. Oh, there's 2 decimal here, so I'm going to move my 2 decimal places out. There's 1 decimal here, 1 decimal here for a total of 2 decimals. So 1 times 1 is 1, 1 times 2 is 2. I'm going to add 0 because I'm multiplying it by 20. 2 times 1 is 2. 2 times 2 is 4. I'm going to add these down. I get 441. And now, since I had 2 decimal places moved, one for the top number, one for the bottom, I'm going to insert that decimal place back here in the 2 decimal places. Awesome. All right, now let me get 2.9 times 2.9 real quick. 2.9 times 2.9. Okay, again, this is going to be 2 decimal places total. 9 times 9 is 81. Carry my 8. 9 times 2 is 18. Plus 8 would be 26. Add my 0. 2 times 9 is 8. Add 1 to 2 times 2 is 4, which is 5. Add these guys together. And I get 1, 4, 8. So I get 8.41. All right. So now that I've evaluated my squares, I'm going to plug those into my equation. And I'll get 4.41 plus b squared equals 8.41. I'm going to go ahead and solve this for b, right? So I'm going to subtract 4.41 from both sides. I get b squared equals 4. And now, well, I'm looking for b, right? So if b squared equals 4, all I have to do is take the square root. But b squared, the square root of b squared would be b. And the square root of 4 will be 2. So our unknown side length here is 2. Awesome. I hope you guys are able to use this, and this is helpful for you guys to understand how we can apply the Pythagorean theorem to find unknown lengths of a triangle. If you need help, let me know. Thanks so much.